Okay, folks, we're going to do a law of cosines lesson here. And remember the law of sines we did before this. We use law of sines when we do not have right triangles, so we cannot use SOHCAHTOA. And same thing for law of cosines. We cannot use SOHCAHTOA, but we're still looking for a missing side or angle. And so this is another option for us, another tool in our toolbox. So here is the law of cosines, and this is written in respect for all three different sides of the triangle. And you just notice here that I've kind of color coded some things. The a squared, the side a squared, does correspond with that angle A. So it's opposite angle. So when we set up the law of cosines, you take the cosine of the angle that is opposite of whatever side you're setting the problem up in respect to. So if I set it up in respect to this side A, then the angle I use in the cosine is the angle that corresponds and is opposite to. Same thing for if it was in respect to B or C. So let's take a look. Here we're going to look at finding a side, and we are not going to be able to use law of sines because if we tried to set it up, we would have too many unknowns. And another thing to point out is if we are looking at the congruence postulates, when we're going to do law of cosines, we would have a side, an angle, and a side. So when we have a side, angle, side, and we're looking for another side that's opposite the angle, we're going to use law of cosines. So let's set it up. We would have the side that we're missing, in this case x squared, equal to the two other sides squared added together. So that would be 21 squared plus 24 squared minus 2 times those values times, I'm going to run out of room here, so I'm going to move this over actually. I'm going to move this out of the way for a minute. Times the cosine of whatever angle is opposite of x, in that case is the only angle we're given, 42 degrees. Okay. Now at this point, we are pretty much all set to go here if you have a decent calculator. And you can take x, which is going to be, if we take the square root of both sides of these equations, we are going to have solved for our x. So all I need to do is basically take the square root of this big long expression here, and I'm just going to type it all right into the calculator and use that calculator to the best of its ability. So I'll pull that up and show you how that's done. So what I did, and we use the TI Inspire calculators in our room, but I just typed in that whole expression inside a square root symbol and hit enter one time, and we get 16.36. So does that answer make sense? Let's go back and take a look at our problem and see, does 16.36 or so, does that make sense for x? So does that look like it could be 16.36? And it does. It seems like a realistic answer. Okay, so that would be how you would use law of cosines to find a side. It's just a bit more challenging now to find an angle with law of cosines because you have to use a little more algebra to solve for it. So here I would have my opposite side and my angle. Right here I have my 14 and my x. So if I'm looking for that x, then I start out with its opposite side, starts out the whole equation. So that would be 14 squared equals the other two sides squared added together. So 8 squared plus 13 squared minus 2 times 8 times 13, those same numbers, times the cosine of, in this case, I don't know, x. So my variable, what I'm solving for is this cosine of x right here. So I want to get everything else on the side all by itself and then take the inverse cosine of whatever that value is. So I'm going to clean this up a bit here, and I'm going to go ahead and let's see, if I square that I get 64 and then 169, and then if I add those two together I'm going to get 233 minus 2 times 8 times 13. Okay, 2 times 8 times 13. Let's make a quick calculation. I don't want to make any mistakes here. 2 times 8. 208 cosine of x. And that is equal to 14 squared, which is 196. Okay, now the biggest mistake that I see when people are using law of cosines is that it's so tempting. It's so tempting because these numbers are pretty close to each other. But students will take these two numbers and they'll subtract them. And you can't do that. That is illegal. That's an illegal move. That would be like saying, and I know all of you know this, 233 minus 208x. Can you subtract those and combine those? Answer is no. Why? Because they're not like terms. You cannot subtract those. So that is the biggest law of cosines mistake that we see. So instead, what you have to do is get this 233 over to the other side by subtracting it. So I want to take that 233 away from both sides of the equation. And so when I do that, I'm left with, I believe, negative 37. And that is equal to negative 208 times the cosine of some angle I don't know yet. And again, remember our variable is this part right here. So remember, there's our variable. There's our variable. We're trying to get it all by itself here, and I'm almost there. I just have to get rid of this negative 208. Well, how is this negative 208 bonded to the cosine of x? It is multiplied. So the inverse of multiply is to divide. So I'm going to divide both sides by the negative 208. And now I will have my cosine of x all by itself because those can be a factor of 1 and I can get rid of them. And so what I have here finally is the cosine of some angle, I don't know yet, x, is equal to a negative divided by a negative is a positive anyway, so it will be equal to 37 over 208. So that would be what angle corresponds to the adjacent side of 37 and the hypotenuse of 208. So to solve that, you would use the inverse cosine of 37 over 208, and that will give you a corresponding angle of x. Looks like the cosine inverse of 37 over 208 is 79.75. So does that make sense? Is this a realistic value? 79.7 or 79.8, I guess I can't remember. 79.8 degrees. Does that make sense for this angle? Okay, and it looks about right. So that would be law of cosines finding an angle. It's a bit more of a process than finding a side, and you have to be a little careful. And remember, the biggest mistake that we see is students will take these two things and subtract them. Do not, this is hard to read, do not subtract these. If you subtract those, you're going to make a mistake.